How to implement ORMs using repository pattern. Are you curious about how to implement object-relational mappers using the repository pattern? This method can simplify your backend development and make your code cleaner. Let's break it down step by step. First, let's clarify what we mean by object-relational mapper. An object-relational mapper is a tool that connects your database tables to programming language objects. This means you can work with data as if it were native objects, rather than writing complex structured query language statements. Next, we have the repository pattern. This design pattern provides a way to access domain objects from a data source. It hides the details of how data is accessed and manipulated, making your code easier to manage. Now, let's get into the steps for implementing object-relational mappers using the repository pattern. Start by defining your domain models. These are plain objects or classes that representing your business entities, like product or user. Keep these models independent of your database schema and object-relational mapper specifics. Next, create repository interfaces. These are abstract classes or interfaces that declare methods for common data operations. Think of methods like get, add, update, delete, and list. This contract allows the rest of your application to interact with data without needing to know how it is stored. Now, implement the repository classes. These concrete classes will carry out the actual database operations using the object-relational mapper. For instance, if you are using Python with SQL-Kami, your repository methods will translate domain model operations into object-relational mapper queries and vice versa. It's also important to map between your domain models and object-relational mapper models. Since these two can differ, create mapping functions to convert object-relational mapper entities to domain models and back. This keeps your domain logic separate from your persistence logic. Next, use dependency injection. This means you will inject repository instances into your service or controller classes. This makes it easy to swap out repository implementations, like using a mock repository for testing instead of a real database repository. If you want to take it a step further, consider implementing the unit of work pattern. This pattern helps coordinate multiple repository operations within a single transaction, managing the object-relational mapper session or database context. Let's look at a practical example. Define a product domain model with attributes like stock keeping unit, name, and inventory quantity. Create a product repository interface with methods like get by stock keeping unit, add product, and update product. Then, implement the product repository with object-relational mapper calls using tools like SQL-Kami or Entity Framework. Map the object-relational mapper entities to product domain objects inside the repository. Finally, use the repository in your service layer to perform business operations without making direct object-relational mapper calls. The benefits of this approach are clear. You achieve a clear separation of concerns between your business logic and data access. It becomes easier to switch databases or object-relational mappers without altering your business code. You can also simplify unit testing by mocking repositories and reduce duplication of data access code. By following these steps, you can make working with databases more straightforward and maintainable, aligning with good software design principles.